Hey guys, what's up? Mr. Catlin here with help on your algebra homework, lesson 11. We're looking at these perfect squares of quadratic expressions, and it makes sense to call this an expression that's a perfect square because we got to explain why. So we're looking for the reason that we're making this a perfect square. So one of the things that we're looking for a perfect square is it's going to follow this general format algebraically. Okay. So the general setup is you're going to have an x squared term, which we do. You're going to have some number that's being doubled. Okay. So like 2n x. And then you're going to have that same number that got doubled getting squared as the constant term. Okay. So whenever you're looking for this, you kind of start at the constant term. The constant term's got to be some number you can square and get a good number. It's got to be a perfect square. So in this case, the 100 can be squared. Square root of that is 10. So 10 times 10 gives us the 100. And if you take the number 10 that you squared, took the square root of, and you doubled it, will it give you the linear term? When you doubled that in, would it give you 20? Yes, it does. So why it makes sense to call this expression a perfect square? Well, you could say something like x plus 10 times x plus 10 equals x squared plus 20x. And since these factors are identical, it's the square root of x squared plus 20x plus 100. You could also say something like we wrote in our notes. You could say the constant term's square root doubled is the linear term. That would be another sentence that you could write here. Just kind of showing that it is the perfect square quadratic because it has a factor that you can multiply by itself. Now, you can use that knowledge to solve equations like we see down here at the bottom. So if you see an equation where you have a perfect square quadratic equal to a perfect square number, you can take both of their perfect squares, their square roots, like the square root of this is, like we just saw, x plus 10. And the square root of 81 actually has two options. Okay, the square root of 81 could be 9 times 9, or the square root of 81 could be negative 9 times negative 9. So this kind of has two different ways that you could work this out. So we're going to solve both, and we'll have both of the places that the parabola crosses the x-axis. We subtract 10 from this, and x would be negative 1. And we subtract 10 from this, and negative 9 minus 10 gives us negative 19. And these are the two places where it would cross the x-axis. I need to see this for showing work. Don't just write the solutions, okay? Either go Han's method of where you work it out and show what it's equal to, or Jada's method like we saw in class, where she just solves it for the positive and the negative square root of 81. All right? So one of those two shown work for full credit there. See you guys later.